Hi everyone, my name is Tian Xin. Today we are here to give a presentation about smart concrete. I will begin our presentation with smart concrete introduction. Concrete is widely used as construction materials in the world. This old mixture has successfully turned into a new technology which known as smart concrete. It was developed by Dr. Deborah Diao Chong, an engineer from the State University of New York at Buffalo, US. Carbon fiber is added into concrete as a new composite material as it increases concrete ability to sense strain, cracking, or damage in itself while maintaining or even enhancing mechanical properties. For physical properties in smart concrete, the compressive strength, split tensile strength of concrete are all improved. Concrete becomes very rigid and it is electrical conductive because of the presence of carbon fibers. Carbon fibers also increases concrete durability and decreases its porosity. For its chemical properties, smart concrete is chemically stable as carbon fiber is corrosion resistant. In addition, carbon fibers are brittle. It is formed by strong covalent bonds, hence it allows for the propagation of cracks.
Thank you, T. And hi, I'm Justin, and today I'll present about the process or the procedure in smart concrete. And first will be the material manufacturing and application process. First, cement, sand, silica fume, which is 15% by the weight of cement, and mighty cellulose, which is 0.4% by the weight of cement, and gravel. 5 of them mixed together for 5 minutes in a mixer. As lump of carbon fiber reinforce, cement tends to decrease due to the increases of carbon fiber content. So we need methicellulose to maintain the mortar at the reasonable flow value in the range of 150 plus 50 millimeters. Silica fume and methicellulose as raw materials are added to disperse the fiber. Silica fume serves to enhance the fiber matrix bonding. So second, water along with the water reducing agent, which is Tamil SN, and the carbon fiber, which is 0.5% by the weight of cement, and mix for 1 minute at low speed, casing the concrete into mold and consolidating the mold concrete using a vibration table. Next is the specimen will occur at a standard temperature of 20 degrees centigrade for 20 hours after casting. The next step will be removed and subjected to 48 hours of steam curing at 70 degrees Celsius. And the last step will be specimen will dry at a temperature of 50 degrees centigrade for 7 days. So next we come to the standard test process. And the first one we will using the compressive strength test. First, prepare and place the concrete mix in mold for casting. Next, once it sets 1 day, remove the concrete cubes from the mold. Keep the concrete cube submerged underwater for stipulated time. The specimen must be kept in water 7 days, 14 days, or 28 days, and for every 7 days, the water must be changed. After that, the specimen will be dry before placing it on the universal testing machine, which is UTS. The weight of sample is noted to proceed with testing. So, testing specimens are placed in space between the bearing surface. The concrete cube are placed on the bearing plate and aligned properly with the center of thrust in the testing machine plate. And the loading must be applied axially on specimen without any shock and increase at the rate of suggested 140 till the specimen collapse. If the load is applied and the sample is cracked, or we say the specimen is collapsed, the crack is known as the compression satisfaction and the reading is recorded. The next standard test will be the electrical resistance test. First, set up the test cell by placing the stainless steel wire inside each cell cups and tighten the corresponding connectors and prepare the concrete sample. Next, put the concrete specimen inside the space ring and the rubber gas cap at the other end of the place the cement sample with ring between the cell. Insert the bolt with washers into each four corners of the cell, and the washers and nuts should be attached to another end of the bolt and tighten firmly. Fill the black cell with 3% sodium chloride solution and red cell filled with 0.3 normal sodium hydroxide solution. After that, place the cell in the position with the filling inlets facing up to prevent the leakage. Place the temperature sensor in cell with a connect to the negative terminal of the thermal device. Next, connect the red cable to the red jack of the cell to the red jack of the device, black cable to the black jack of the cell and to the black jack of the device. And last will be after ensuring all connection is connected properly. So we turn on the device and the reading is recorded. And that's all from me. Thank you.
My name is Ng Qian Hui. So I will now continue our group presentation with the discussion part. Use of concrete in the construction industry had caused environmental issues on huge energy consumptions and air pollution due to the carbon dioxide emission. So in Malaysia, the government has been practicing sustainable constructions as they are aware of the consequences of the construction sector. So for the benefits of smart concrete on sustainable constructions, first, smart concrete can detect and respond to damage and deformations. It also helps to track the progress of cracks and reinforcing them to make them stronger. So, with the self-sensing concrete, buildings will have a longer service life and minimize the danger of certain structures on human safety. It also poses high sensitivity, durability, and simple installation as we compare to the traditional concrete. The self-sensing concrete extends the flexural strength, toughness, and freeze-thaw sturdiness. So lastly, smart concrete can decrease the drying shrinkage and electrical phenomenon. It plays a vital role in safety and reduce resource and energy consumption. The applications of smart concrete. So smart concrete is widely used in the sector of structural health monitoring, traffic monitoring and detections, weighing in motions, and border security. So the route made by smart concrete might be able to identify whenever every vehicle was, its speed, and its weight. So these are all the benefits and applications of smart concrete. To conclude, concrete as a construction material is used worldwide as its first-rate properties. However, this material will easily crack because of its low tensile strength. So smart concrete is thus invented, and it has a very big category of material that covers self-sensing concrete, self-adjusting concrete, self-healing concrete, and so on. So smart concrete will bring a very big revolution to the field of conventional concrete material, which have a beneficial impact on society, economics, and the environment. So that's all from our group. Thank you.